Welcome to the Wild Ag Podcast, where we'll serve as a connection point for landowners and conservation professionals who want to integrate conservation and agriculture. I'm Dr. Andrew Little, Professor of Landscape Ecology and Habitat Management and Extension Specialist at the University of Nebraska.
And I'm Nate Pfluger, Precision Ag Coordinator for Pheasants Forever and an avid outdoorsman with friends and family in my free time. Together, we'll work to bring you perspectives from both landowners and conservation professionals for discussions on soil, water, and wildlife in ag-dominated landscapes.
All right, welcome back to the Wild Ag Podcast. I'm here with my co-host Nathan Pfluger, and my name is Dr. Andrew Little. Today we have the great fortune of having Crystal Powers here today joining us and going to talk about the topic of nitrates. So Crystal, would you mind giving a quick introduction about yourself?
Sure. Thanks for having me on, guys. My name's Crystal Powers. Currently, I work at the Nebraska Water Center as a statewide water management extension educator. And it's been a fun pathway to get here. I've always been interested in water and natural resources. I grew up down in the south central part of Nebraska along the Little Blue River, and so have fond memories of playing in the water from that time. And so it's a great joy to get to continue to do that. My degree program is in biological systems engineering, where I focused on kind of that intersection of agriculture and the environment, and then continued that at Cornell University, and then came back to Nebraska to share what I've learned. So I've been working here first in biological systems engineering, and now I'm over at the Water Center still talking about that lovely intersection between how we make sure that we support that natural resources foundation to our agriculture system.
Sure.
Well, that's great because, just out there working with landowners, nitrates is just a huge conversation, not only amongst agricultural producers, but even within cities too. So it's definitely something that affects everyone. So I think it's a very important topic to cover. So happy to have you.
Yeah.
Do you want to lead off with some of just the history about the nitrate issue here in Nebraska?
Sure. And we'll just start with nitrogen is such a critical component. That's why it's one of the main crop inputs. It's what drives growing a plant.
Sure. And
then it has become very common in our water supply. So this is why it impacts pretty much everybody in our state. And so just for a little bit of fun trivia, I wanted to ask you guys, when do you think, let's start on the ag side. So we'll do a little bit of ag and we'll do a little bit on the drinking water.
Okay.
But when do you think the University of Nebraska first had its recommendations for inorganic nitrogen?
On the ag side, I would guess that'd go, I would guess probably early 80s, just because, there's been a lot of research around agriculture, nitrogen, and all sorts of stuff like that, in my opinion. That'd be my guess, early 80s. I was going to
say like late 70s, like maybe early 80s, yeah.
I'll give you a hint. So nitrogen, commercial nitrogen became a thing post-World War II.
Okay.
And so we started researching it before that in the 1920s at our ag research stations.
Oh, wow.
So our first UNL corn nitrogen recommendation was 1944.
1944, wow.
So even before World War II was over, we didn't really see a lot of commercial nitrogen until kind of that post-war time, because those plants got converted post-war, but we already had fertilizer recommendations way back then. And so when do you think, and we'll stick with the ag side, when do you think we first started adding nitrogen into irrigation water? So that's called fertigation's the fancy word, but...
As in, like, we were pulling it up knowing that it was in the groundwater, you're saying?
No. So, like, adding our actual fertilizer.
Like having the tanks and...
Having the tanks, putting it in our... So that... Because one of the things, that helps get it out there right when the crop needs it during the season. When do you think we kind of first started that practice in Nebraska?
I'll go 75.
Yeah, I was going to say like 68, 69, somewhere in there.
1949.
Oh, wow. I am way...
That's what's fun about it. It was all a surprise for me, so don't feel bad. So, and we already so UNL's second set of nitrogen recommendations in 1947 was already saying we need to minimize leaching losses by applying it in season and really being efficient in our irrigation use, because we already knew in 1947 that we'd lose that nitrogen with the water.
Wow.
And then so as part of that, we started saying, well, if you put it with your irrigation,
Sure.
then you get it right there in season when they need it.
So we knew it was leaching because of the water, right? Carrying it down. Did we know where it was going back then?
Right. So we'll flip over to that drinking water side. When do you think the state of Nebraska, so this isn't even globally, just in Nebraska, when did we first identify nitrate as an issue in drinking water wells?
I'm going to say probably in the, I'd say probably late 60s, early 70s.
We're at least backing you up a little bit.
Okay.
The Nebraska Department of Health had its first full report, so we probably knew about it before that, but they already had a report on it in 1940.
Did they really?
Yeah.
Wow.
And
Well, I need
so
to start
we
shooting for the 40s now
knew
with my
in
numbers.
a poorly constructed well, and so that was ahead of kind of this commercial fertilizer. So in that time, it was mostly manure based.
Sure.
And so they knew things from manure could get into your well,
Sure.
and that one of the things they already had identified by that time was the nitrate itself. So in a related vein, when do you think they research first said we'll talk more about all these, but 10 parts per million is the drinking water standard now. But when do you think they first identified that number for the health standard for nitrate?
1955.
Oh, you're getting closer.
I was going to say like
You're going in.
1950, like 2 or something like that.
1951.
Oh, okay.
Because like I said, that was based on a bunch of Midwest states really led the way because they were seeing it, like I said, that 1940, the Department of Health was already looking at it. So there was research throughout the 1940s.
Oh, sure.
And so they did a big research review, so a literature review in 1951 recommended from all of these studies across the globe that 10 to 20 was probably the safe level for infants.
Wow.
So that's why, it's,
Yeah.
And then the last trivia question on this history piece is, when did the U.S. officially adopt 10 parts per million?
That's a good question.
So we know we had the research side.
Yeah.
I'll stick with my 55 answer.
Let's say 1960.
Right. Well, you're closer. It does take us a while to get from research to policy,
That is
but
true.
1962, it was a while ago, because a lot of people, there was a change and it became more formalized in the 1990s. And so a lot of folks know about that piece because in the 1990s, it became a legal requirement.
Oh,
But
okay.
clear back in 1962, at the time it was the U.S. Public Health Service,
Sure.
said that was the recommended level. So at that time, it was a recommendation. And then in the 1990s, it became a legal requirement.
Okay.
It's been around.
Wow.
Yeah,
We've
definitely
been
not a
talking
new
about
issue.
this topic for a long time.
So it's not a new thing. So it's been around for a while. That's cool.
So you kind of mentioned they kind of drilled down on the nitrate. What is nitrogen compared to nitrate? What is that?
So nitrogen in the environment changes into many different forms. So the largest component of air is nitrogen, but that's N2 gas. And so it's very inert in that form. It's the largest component of our air. But then when we talk for growing plants, nitrogen is what helps the plant grow. It's a big portion of protein. And so there's all these different forms that it can turn into so that the plant can take it up and use it. And then, it gets excreted like through livestock manure. That's where we see it. We don't use all, the humans or animals that eat the plants. We use part of it. We need protein. So we use part of that nitrogen. But some of it also comes out in manure. And so there's this whole cycle that happens in our natural environments. And for really the entirety of growing crops, nitrogen's been one of the limiting factors. So we've always been really interested as we've grown crops, how do we make sure it gets plenty of nutrients? For thousands of years, that was primarily through livestock manure. And so the system. But then we discovered the process of how can we take that atmospheric nitrogen and turn it into a fertilizer.
Oh,
And so
okay.
that's the commercial. That was a Haber-Bosch process. It won a Nobel Prize back in, I think it was 1909. In 1909, we discovered how to take atmospheric nitrogen and turn it into a fertilizer that plants could use. And now there are many, many types of
Sure.
fertilizers that come in different forms of, like we're just mostly talking the nitrogen side of fertilizer. There's other plant needs, but we'll stick to that space. It's complicated enough.
Oh, sure. Yeah.
But once you apply those, then there's microbes in the soil that can convert it to different forms that the plant can use. And why nitrate becomes an issue is because it's water soluble, which that means that
okay.
it fully goes into the water, and where the water goes, so does the
Okay.
nitrate. And so when it's there in the root zone for the plants,
Sure.
that's where we want it so
Sure.
that it feeds that plant. It just becomes a hazard after it leaves. You know,
Sure.
and farmers don't want to see it leave either because they
Sure.
pay,
Oh,
for
yeah,
commercial
pay money
fertilizer,
for it.
you're paying money for that.
Oh, yeah.
That's a critical component to your crop growth. So you don't really want to see it leave. And
Sure.
so we're kind of unified in that sense of we don't want to see it leave, but it becomes very mobile once it's a nitrate. And so that's how we usually see it turn up in the
Sure.
water. So that's why we talk about nitrate in the water side. And in the drinking water standards, it's about nitrate because that's the form that nitrogen's in when it's running around with
Sure.
water.
And I'm sure we'll get into this in more detail, but as one, say, for example, a producer puts nitrogen out there, and again, obviously it depends a lot on how much water they're going to have in that field from rainfall or irrigation. But is the process of that leaching down? Does that, like, what's a time frame? Do they have kind of estimates on how long that typically takes? I'm sure, as anything, there's a lot of it depends, but I'm just kind of curious, like, is it like years or is it months or like what's that time process look like?
So we kind of talk about it in a couple buckets. There's kind of a fast path and then there's
Okay.
the slower path.
Okay.
And so depending on what form that nitrogen is in, like I said, we talked, there's
Sure.
many. So if it starts, there's some fertilizer products where it's already in a nitrate form,
Sure.
it can start moving right away. And then what drives it is how much water's out there.
Sure.
So in a very wet season, it can move very quickly depending on your soil type. Like I said, so there's these big buckets. What's the fertilizer form? How much water's out there? And what's your soil? So if you've got a clay soil, it moves it's these tiny particles, so the water has to go very slowly. It can take a very long time to move through a more clay soil. And so it takes years to move. So it's moving, it's moving an inch or less a year
Oh, okay.
in a heavy clay.
And
And then
heavy
the
clay.
other extreme is a very sandy soil.
Sure.
And in that space, it can move 7 feet a year.
Oh, wow.
And so it can be moving
Yeah.
very quickly in a full sand. And most of our soils are in between those
Sure. Yeah.
extremes. And so the last piece of how long till you drink it
Sure.
is how far does it have to travel to get to where your
Oh,
drinking
sure.
water comes from? And so in some portions of Nebraska, if you talk about the sandhills, which I know you guys have talked about on the podcast before, those sandhill lakes, that's the groundwater surface
Oh, sure.
that's
yeah.
above ground.
Yeah.
Or in our river valleys, it's 3 feet down, 10 feet down. And it tends to be sandy. So you can get that nitrate movement in a single year, or
Yeah.
probably less, really.
Yeah.
And when we look at age dating, those waters, river valleys, it's under 10 years old, all the water in the valley, because it just moves
sure.
really quickly
Yeah.
in
That
those.
makes sense.
Now, if you look at a really deep soil out like in our rainwater basin area, for example, which I know you guys have talked about. So like it's 100 feet to groundwater and a heavier soil. So it's decades from
Sure.
what happens on the land surface until it gets down there to the groundwater. And so it can be very quick
Sure.
or it can be
No,
very
that's really
slow.
cool. Yeah, I've always wondered that, like how long that process usually takes, and I figured it depends quite a bit. So,
Well, and
That's
that's a good point to bring up because a lot of the discussion around, at least what I hear around the nitrate issue, is it's a legacy issue, right? It was something that happened historically that has caused the issue. And so maybe that's not true. In some areas it is true, but then in other areas it's definitely a lot more recent of an issue or
Yeah, it's definitely a both situation.
Sure.
And so when we go, if we kind of keep those two buckets of fast and slow, which, it's not a biennial question, but we'll keep it that way. So in those river valleys and our faster flowing systems, everything that you're seeing in those water samples is in the last 10 years. And we've done some research studies where we take soil cores from the surface all the way down to the water table, which, like I said, some places is very short, some places it's 100 feet. And so you can kind of track how that nitrogen moves down through that. So, and we're seeing the same of that there's still stuff we're adding in the recent time that's causing levels to increase. In a slower system, that's one of our biggest challenges, is that what happened several decades ago is still working its way down to the groundwater. And so in those places, we've got places that have 300 to 1,000 pounds of nitrogen every acre on its way to our groundwater.
Wow.
So we talk about that zone as kind of an early warning system for, cities and towns and private owners of here, it's on its way. So we're going to be dealing with this challenge no matter what we do on the land surface today. Sure. But that's not to say we can't see improvements really quickly in those faster systems. So in those places, we can see things that we do have an impact right away within the first few years. And so those can help us really figure out what do we need to do to really get at the problem. Places like the Central Platte who've been doing this for a long time, they've been able to stabilize some of those levels so we're able to show that we can make progress on it. Because that's the other part that I find unfortunate about the legacy conversation is it makes it just seem like, there's nothing we can do about this.
Yeah.
And a little bit, yes. But we can also in these faster systems really look at change and seeing how we can make improvements. Yes, we're going to have to deal with some of that stuff that's there, but we know we can make progress by looking at those what's happening in the valleys.
So we kind of touched on it a little bit, just the different types. So in the areas where it moves faster through the soil, would it just be as simple as applying a different type of fertilizer that's not in the nitrate form? Would that help out
that's
those areas?
A really complex question. And so I'm trying to think of how to break it down. I mean, part of the reason for talking about the history at the beginning is to say, if this were easy, we could have figured it out a long time ago.
Yes.
And so it's one of the most important parts of our ag environment system, but it's also one of the most challenging because there's it's such a dynamic system. And so we kind of have a whole package of what we'd say of how do you get more efficient. And we've seen this over time from when we first started using fertilizer to today. Farmers have continually made progress in how much crop they can grow for the same amount of fertilizer. So I don't want this at all to seem like we haven't been working on it. And so there's kind of there's a great history of farmers getting more efficient. There's a great history of our local policy, finding ways to help support that. How do we incentivize those improvements? And so this is a really great decades-long work by, this is a multi-generational at this point of people in Nebraska coming together to really think about how do we get better. And so with that bit of context, I mean, there's several things. There's three big buckets, I say, on the ag side. And this is true, if you're a homeowner too, listening to this. In Nebraska, that's a very small percentage of acres, but we can all help contribute to improving it. So there's how much nitrogen you put out there, and we can talk a little bit more about that. Then the second is how much water is in your system. So in Nebraska, where we're heavily irrigated, we have control over some of that piece. And then the third bucket is soil health, which improves how both of those work. How well we retain the moisture, how well nitrogen's cycling, do we keep it in living plants so that it doesn't leach, is kind of that soil health. So it kind of fine-tunes the first two big buckets.
That's really cool. Yeah, because I'm thinking you mentioned there, like even like kind of the urban side, and obviously a lot of folks, including myself, I'll put out some fertilizer and hope to have a nice green lawn, but also knowing that sometimes that can cause other issues, and I've seen that just throughout the country where you'll see obviously very similar issues. You get algal blooms will come up, and in the summertime you get a lot of fertilizer running off and stuff, and so then that creates additional problems. And so, yeah, that's definitely a common topic kind of universally across the landscape for both rural and urban. So,
and that's a good point to just clarify a bit too, is most of what I'm talking about is how nitrogen travels through the soil. So we call that leaching process. Sure. And there can be issues with nitrogen being lost in runoff. Maybe for simplicity's sake, I won't talk as much in that space. In Nebraska, we have very well-drained soils for the most part. And so while we do get runoff, and I don't want to minimize that we do have to address challenges there, most of what we're talking about is how do we minimize leaching losses, which are, sometimes there's similar practices that can help with both. Getting the right amount of fertilizer at the right time certainly helps for both. And same with even with irrigation management, you don't want your soils too wet so that it runs off.
Sure. Yeah.
So, I mean, there's
absolutely.
definitely overlaps between the two buckets.
Yep.
And that's one thing that's a little different about nitrate in Nebraska versus nitrate in Iowa. They're just across the border from us. So we both have both. But Iowa leans more heavily in their dealing with runoff issues. And so you hear a lot about the Gulf of Mexico hypoxia zone with that runoff, what's in their surface waters. In Nebraska, the majority of what we're talking about is we're sinking it into our aquifers and our groundwater system. And both are really critical. We get drinking water from both sources. Algal blooms and dead zones are critical issues on the surface water side. It's just we kind of tip more heavily just based on kind of our climate and our geology, I guess.
Yeah, well, I know like over
that.
there, well, like prairie strips, we have them now as part of our labs of work, and that's something that started over in Iowa, and that they put them a lot in the downslopes with the intent to try to reduce that runoff you're just describing. And so I know nitrogen is one of those things they've looked at, and phosphorus as well, and potassium, all of them, to kind of look at runoff levels and how those strips can actually help, and they can dramatically help in those cases. So, and of course, it's a little, like you said, it's a little different challenge in that sense. And especially, we kind of joke with prairie strips, they put them on downslopes, and then we go out and we think about a site like Clay Center in Nebraska where it's about as flat as a pancake, and they're not really thinking about topography as much. So.
Well, and that's why there's no silver bullet to address. I mean, because in Nebraska, we still have some lakes that have algal blooms. So that's why I don't want to minimize that we need to think about both the surface water questions and the groundwater questions. Yep. And like I said, there's some practices that landowners can do that help for both. There's some that are more targeted at surface water. There's some that are more targeted at groundwater. And so that's why I really encourage anyone who has lands they own, even if it's your yard or larger tracts of land, to really think about the context that your land is in and figure out what's the right questions to be asked. And there's great people to talk with that can help advise you on that, to kind of help you identify what are your priorities for your land. Yeah. And, because things like perennial vegetation are a great way to address kind of both situations if they're put in the right places. Yep. And because one of the things we see is this is particularly a challenge in places that are in row crop agriculture, because that's where we're adding more nitrogen. The crop's only out there for 6 months of the year, and then you've got bare soil the rest of the time. In more perennial systems like a lawn or a rangeland or pasture, you've got living roots most of the year. Sure. So even if the plant's dormant, you still got roots. It tends to hold both water and nitrogen more easily. And then since you have that longer growing season, that plant is actively using both water and nitrogen. So it just keeps everything cycling higher up in the soil profile, and you tend to have less leaching losses in those perennial systems. Sure. And so I think that's why there's a great place for this I know a lot of the Wild Ag podcast is about perennial systems management. And so how we can combine those two to kind of optimize what's happening on the landscape. And even things, that's why we talk on the soil health side about cover crops, of getting something living out there so it keeps the water and nitrogen up on the land surface, and then, timing it right so it's available for your crop the next year.
Yeah. No, that's huge. And that's actually, I was going to ask you about, was on cover crops. And I know, Nathan, you work a lot in that realm as well. And because I've always envisioned, like, it'd be great driving down the interstate and being able to see a lot of green fields and through the fall and the winter time frame, where basically you have essentially, like you said, kind of like living things throughout the entire year. Will be optimal. But obviously, I know it's not easy. There's a lot of challenges that go into that. But my understanding is adoption is increasing. It's just not always just a exponential type of increase. So
yeah,
right. And so it's a whole new crop. It's and getting the timing right. Like I said, we can definitely see the benefits on the soils and the nitrate side. But figuring out that right mix. And we're doing research here on campus of like, how do we get the seeding time right? And,
sure.
And there's even like engineering research on how do we make this an easier, can we apply it at the same time as we're already out doing field work so that it's not an additional pass. And so it's a great research space as well as then how can we get it into farmers' hands? There's policy incentives in that space. To really make it work for everyone involved. So, just because we see a practice that benefits nitrate, it also needs to work within the larger context of the growing system. And kind of coming back to the nitrogen, like I said, that's kind of the soil health side. I didn't fully answer your question about the type of nitrogen.
You're okay. There's a lot to discuss around this issue. Well, and I just like how you're painting the picture that we're not putting all the blame on the landowner. It's really an all hands on deck approach. I mean, I think you can see that with your nonprofit organizations, TNC, Pheasants Forever, trying to work with growers with cover crops, or even the NRDs doing their part. So I just wanted to reiterate that we're definitely not coming off that this is a landowner issue only.
Yeah, it's complex. And going back to your earlier dates in the 40s, it's like, geez, I didn't realize that this has been such a, common thing for so long. And obviously just a lot, like you said, complex. It's not just easy. If there was an easy button, just like any of the other things we work in, that'd be great. We could have pushed that a long time ago, but that doesn't exist. And so I think, to your point, Nathan, I think that's exactly right. That, it is complex, and ultimately, producer, they're working to take and feed and fuel the world. And so we got to be able to do this efficiently. And we'll probably eventually get into some of the technologies here at the end of our conversation, and that ways that you can kind of help, do that, really precisely on the landscape as well. So,
and I have a question about, so this might steer us back to the forms of nitrogen. Can nitrates, or do nitrates also come from animal feces? Mm-hmm. Okay. So it's not just
and that's like I said, a lot of those in the 1940s, that was the primary fertilizer source. So a lot of those initial studies were in places where it was too much manure. So if you had like a livestock yard, and then you had more cistern wells were common then, so they're really shallow, and it was very easy. That was, so like if you played Oregon Trail, like I'll tell my age a bit here.
I did that.
You died of dysentery. Like those were things that were because we had these shallow wells that it was very easy for manure and other diseases to get into. And that was just very common because we didn't have a lot of the equipment that we now do to have better wells. So a lot of those early studies with infants, so that was also, infants on formula, like we can kind of cover that piece a bit of, so infants don't have the ability to convert nitrate in their stomach. It's so when you're for sure under a year old, I don't remember the exact timing, but for sure infants under a year old can't convert. And so then what it does is it binds to the hemoglobin, which is the part of your blood that carries oxygen. And so if your blood can't carry the oxygen, it's like you're suffocating. Yeah. And so the infants, they would call it blue baby syndrome because they weren't getting enough oxygen, they'd turn blue. And so that can happen at a low level or it can be fatal. And so that was what was really driving this. And at that time, it was just from manure sources because you had these shallow wells and you had livestock and it would run in and and you'd have high nitrate levels. Like I said, they found these like dysentery and cholera are different diseases, and there's plenty other E. coli, things you don't want to get from shallow wells. That's why we don't have shallow wells typically anymore. So there's technology improvements on well design as well that came out of this. But part of it was finding that it's not just making sure you don't get pathogens, that nitrate is there as well. And so this blue baby syndrome was what kind of drove the initial research, was because it's an immediate something that was happening. And so that's for infants who were formula fed because they were mixing. It was very common at that time that if you weren't able to produce enough milk, it was still common at that time to do bottle feeding. And it has throughout time, because that's always just, not everyone can fully feed their infants. And so I actually did another deep dive into the history of infant bottle feeding as part of this one time. But long story short, we were bottle feeding some infants. And so they'd use the water from their well. And so that's how they were getting these nitrates when they were under a year old. And so there was a lot of the medical field was really trying to help these families figure out what was happening, what was driving this. So that was what kind of started it. So any form of excess nitrogen is a problem. And so, historically, and it was more in pockets, because that'd be like a home well where you had animals right around it. And then we kind of fast forward to now, we've kind of seen these areas of high nitrates expand. And there's various research ways we've looked at. So now the majority source across the landscape has become commercial fertilizer, simply because that's our most used fertilizer source. We still use manure, and both of those can be used well. We don't need to, we don't have to point fingers. Is it manure or is it commercial? It's simply either one needs to be used well and efficiently. So we'll stop there. But
that works.
So, and there's many types, and I guess I'll stop. There are many types of nitrogen in different fertilizer sources, because we've made a lot of progress on finding slower release fertilizers. Some of that is based on the form it's in. Some of it is coatings that get put on it. Some of it's microbial inhibitors. So there's a whole space of research that's happened about, because we've known, like I said, for a very long time. So there's been agronomic research on how do we make sure that nitrogen gets delivered right when the plant needs it. And so there's a very wide range of products that growers can pick from, depending on when they're applying it and when the plant will need it, because we have wonderful growth curves of exactly when the plant needs it and how much it needs. So it's this really highly scientific space. And the type is just one. How we often talk about it in agronomy is the 4 R's for nitrogen management. And so right rate is the one that is that how much you're putting out. Then there's right type, which is what we were just talking about. The third is right timing. So that's kind of the piece of getting it there when the plant needs it. And then the last is right placement. And so that's kind of this piece. I know, Andy, you've also done some projects where, if you have an area that's not growing crops, or if you put in a conservation strip, can you have precision management so you're not putting the inputs, in this case fertilizer, on those acres because it doesn't need it. So that's really that placement piece of getting it right where the crop needs it, or if you're at seed planting time, the roots, it takes a couple months before the roots get through the whole soil profile. So you put the fertilizer in the furrow with the seed. So there's it's a whole space. And some of that's equipment design. Some of that's research on types. This is a really fascinating. I'm not an agronomist, but I've learned a lot here. But it's actually quite amazing to see the technology that's out there for getting all 4 of those right. And that's what makes it so complex. And that's just the nitrogen side.
And it really speaks to how amazing technology has evolved over time, and that, really over the past, number of decades, because to your point, producer that, they can have very tight margins. So they got to be able to think about, how do I do this economically? I don't want to obviously just put a bunch of fertilizer out there and then lose a bunch of fertilizer. I want to do it so that plant is taking it up at the precise time so that I can have the maximum yield that I can on those acres that I'm trying to produce. And so it's, again, to your point, it's truly a science. Farming, in my opinion, is truly a science, because it's trying to figure out what those little things you tweak. And then there's obviously a lot of variables for farmers and ranchers they can't control, for example, like the weather, and that obviously can influence some of that stuff. And so, yeah, it's pretty incredible. Just the more over the past several years, I've learned about just precision technologies and just farming as a whole, more advanced things that people are doing nowadays. So
yeah, and I think it's important to point out that farmers want to be efficient,
sure,
right? Because that leads, their bottom line looks better when they're more efficient with their products, right? If you're throwing something out there in excess and it's not being used properly, I mean, you're essentially just throwing money away.
Yeah, yep.
So it's definitely important.
Yeah, and the coolest new technology, we've gone from, we were already talking about in-season management back in the 40s, and probably really long before that. But now we're talking about using satellites to help drive that information. Wow. So we're in the space age of agriculture of, we're using high-resolution daily satellite products to drive fertilizer decisions in season. And so we have a lot of control in Nebraska. Having, a pivot goes around every few days. So you can have this really precise control, really being data driven. And so, the challenge being those take time and money to invest in those. And so it's a process as we implement these technologies. But UNL's really been on the forefront of that for the last 30 years. It's been doing precision agriculture research. Then it moved to sensors. And sensor-based research, and really this satellite piece has been driven out of the research happening here at the University of Nebraska. And so that's kind of the piece of how we all work together of how can we help drive research innovations that in the end help both growers and the natural resources of Nebraska.
Absolutely. That's super cool.
And from the satellite standpoint, it's looking at the color of the crop. Is that correct? Or
roughly, they
found
the most accurate. They found the most accurate is near infrared.
Oh, okay.
And so it's not totally the visual spectrum. So the human eye, just watching a crop, or if you have a house plant, if it's starting to look yellow, that means it's short on nitrogen. Well, it can be short on a few things, but most often it means it's short on nitrogen. So for a long time, we've been able to use visual cues to tell us what's going on with our plants. But like I said, the sensors, what they found is we've got really nice imagery of this near infrared spectrum. So instead of the visual spectrum, it's slightly more in the infrared piece of that spectrum, actually picks it up sooner. So we can make a better decision. Like once it's yellow, you're probably starting to have, in critical periods, you're starting to have some yield impact. So we really don't want to wait until it's visually yellow. So they see it in this near infrared first.
That's super cool.
Yeah. Very interesting.
Yeah, it could be a whole nother podcast.
Oh, I know, absolutely.
You could invite over the people who really know all about that satellite technology.
I think this is super awesome because I think there's a lot of really cool applications of that types of technology, not only from the production side of things, but then, as you mentioned earlier, the conservation side of things and being more precise in how we're, managing these systems. Because we obviously, we always talk about in our lab, we have to feed and fuel the world, but we also need to do that sustainably. And how do we do that? And then that's one of the things I love, just meeting with producers across the state and them just sharing about their farms and their operations. And, it's just so cool to see, obviously people want to ensure the sustainability of them. It's just how can we do this most efficiently? And you alluded to earlier with different soil types and things like that. There is no one cookie cutter approach that all producers necessarily can adopt. It may vary if you're in, say, dryland acres or versus, you have irrigated acres. You're in the Northeast or you're somewhere in the basins. All those are going to change how you actually implement management on those acres. So, yeah, it's cool.
And if you want to talk more about the irrigation side, because that's really in Nebraska that when we look at a map of the state and where we're seeing nitrate challenges is primarily on those irrigated acres. And so that's a part that I sometimes see in conversations with even with our policy folks, that they kind of forget that piece of the equation. They definitely see how much nitrogen and even cover crops are really popular now because it's how do you, capture nitrogen so it doesn't leave. But really that irrigation component is the piece where we are seeing it's primarily issue to have nitrates under irrigated acres, not so much on our dryland acres. You can still have problems in dryland, and that's twofold. One is because you don't tend to put as many inputs out on dryland acres because you don't expect it to yield as much because you have a lot more weather risk.
Mm-hmm.
But the main driver, like I said, nitrogen follows the water.
Mm-hmm.
And so this is what is another layer of complexity is not only do you have to be top of your game on nitrogen management, you have to be top of your game on your irrigation management. And so, knowing how much water that crop needs at critical times is really the driving piece. We can't just turn it on and let the pump run because it'll take nitrogen and any other water soluble. There's many things that we don't want to leach out of the root zone. The crop needs it. But the easy button on irrigation is to let it run. It still happens in a few places, but there again, just like we've made a lot of progress in how we manage the nitrogen side of the equation, we've made a lot of progress on our water efficiencies. And both in what growers do and in the policy front, because parts of the state are water short. But sticking to the nitrogen side, we're really wanting to be efficient so we don't lose that nitrogen to the water. Because if you leave your soil wet all the time, the water moves quickly. So how fast the water moves is dependent on how wet that soil is. The wetter it is, the faster it leaches. Historically, we're like, well, then that just recharges the groundwater. Well, yes, but it takes all those agrochemicals with it. And that's what we don't want to see in our water. So we still need to really in season think about using, and there's a lot of great technology in that space has come along to really help us manage that equation of what stage is the plant at? How much water does it really need? When it's teeny tiny, it needs very little. And then as you reach our most critical time is when it's flowering and starting to form the grain. That's when you really it needs fully watered at that time. On both sides of that, it doesn't really need as much water. And so tracking the weather. Mm-hmm. We all love to talk about the weather in Nebraska, and that's for good reason. That really drives what's happening. But we have really great technology that can get you field by field data. It might rain on this side of the road and that side of the road missed it. And so getting really high quality weather information on both rainfall of what's going in and then the water that's leaving the crop is called evapotranspiration. Big word. We call it ET for short. So to figure out how much water you need, it's that combination. How much has come in rainfall, how much has left in ET, and ET drives how much that plant needs. Mm-hmm. So then you can figure out what does that plant need so that you water it just in time. And so we've known you need to manage your water based on the weather. That's just really intuitive. And that's why we're actually really moving that way in nitrogen management as well. Andy mentioned weather drives how much is lost, but it also drives the microbial activity, which is a huge piece of it. And so we might see on the irrigation side, year to year, you can see 10-inch difference. Wow. If it's a wet year versus a dry year, how much irrigation you have to put out there. And that kind of just makes sense. Even if you have a lawn, you're like, well, if it's rain most of the time, I don't even need to turn the sprinklers on. It's the exact same in our cropping systems. It's very intuitive that, if it rains, you don't really need to be putting it out there as long as it's a decent rain. And that's always the question of when do we start? How much do we put out there? And so there is great technology in that space.
And a good analogy of that is you drive around in urban areas and you see the sprinklers going off when it's pouring down rain and you're saying, okay, well, to me, that's where the technology can come into play to say like, well, how much water have we already had? How much does those plants actually need? And as you alluded to earlier, well, like soil moisture meters and other technology, we can really be precise about how we do it. I think honestly, just the evolution of that technology from physically driving out, starting up the pump, to get the pivot going to now you can just control things right on your phone. It's just amazing the technology, how quickly it's evolved over time. So, yeah.
And maybe one little factoid going back to the nitrogen side. So we talked about how much water can swing year to year with weather. I should also bring up on the nitrogen side in our research plots on the exact same field, the amount of optimal nitrogen, we see 90-pound differences. So when you're talking, a crop that you might be doing 180 pounds of nitrogen, but you have a 90-pound swing, there's huge variability year to year. And that's a year-to-year difference.
Wow.
Driven by the weather conditions on that plot. And most of that's microbial driven, which is kind of the cutting edge of the research space is really trying to optimize those microbes. But they're the ones controlling how much nitrogen is mineralized out of the soil. And it's one of our biggest unknowns year to year. Is how active are those microbes going to be? And so that's why we've always said, you need to do it in season and let the crop tell you how much it needs. And like I said, a lot of these tools are making that easier to be able to figure out how much does that crop really need instead of we can get a good estimate ahead of time.
Sure.
But the weather really drives what does it really need. And like I said, and finding out how big those swings are is pretty eye-opening.
Well, I think that also speaks to the value of things like the On-Farm Research Network and other great work that UNL is leading, especially all my colleagues over in agronomy and horticulture, to find those areas where producers can constantly improve and find those edges where they can get better and better over time. And you mentioned that. I think that's where the On-Farm Research Network, to me, is a really great illustration of the kind of co-collaboration of science and producers that are coming and saying, I have these questions, and how can we do this or that, and how do we kind of improve these systems, and then having those conversations not only with the researchers but then with other peers, because they of course have annual meetings in the wintertime to talk about the results they're getting from those different studies across the state. So
can you explain, you mentioned swing. So when you're talking about a swing in nitrogen, are you saying within the soil, like what's still there and what's usable?
Right. So when we go to calculate what a plant needs, like I said, there's kind of two ways you can think of it. You can kind of estimate ahead of time. There's a lot of really good, UNL has an equation that'll help you estimate what's available. And that's had a lot of research behind it. And that was kind of our preferred method for a long time is it'll get you, and they call it the economic optimum. And so you're trying to go for an economic optimum, not maximizing yield, because it's really about trying to keep that farm profitable. And so what is the optimum amount of nitrogen for that field? You can estimate with an equation that uses a lot of inputs. How much is in the soil? How much is in your groundwater? And the soil part is the part that has these changes. Because that is, you can estimate based on how much your soil test is showing and how much organic matter you have, but it's still just an estimate. Those microbes really drive, and that's the largest component of that equation, is how much is coming from your soil itself. And so that's when I say a swing, it's the weather conditions drive that microbial and mineralized component, and that gives the error in those. And so if we go to a reactive method where we let the plant tell us, it knows what it's getting.
Sure.
And we're not trying to guess versus some of these proxies. Like I said, that was the best science for a long time. Like I said, we started doing soil testing kind of back in those 1950s time periods, like soil testing, but it's still a proxy for what the plant's actually getting. So in this case, we're through the satellite technology and sensors, the plant can tell us what it's really getting. And that lets us really hone in on, we don't have to guess how much is being mineralized. Like I said, those were pretty educated guesses. So it's not that they were wrong. When we're talking continuous improvement, we really have the technology now to let the plant tell us exactly what it needs. Even in dry land systems, doing a once in-season pass, a single pass with a high clearance type machine or something like that. So there's even things we can do in dry land, but particularly in irrigated systems, we can really fine-tune it week by week of what that plant really needs and spoon feed it as it goes.
So one question that popped in my mind, I've been thinking about this for a while, and I'm sure others who drive around Nebraska and other states that have a lot of farming, row crop farming, always wondering about is, okay, I see a farmer out in the fall applying fertilizer, and then versus the spring, what are the advantages, disadvantages? Why do people do that? Because that's always something you see people doing. So I'm just kind of curious.
Yeah, and that number has kind of continued to come down, but it is still a practice that I should remember. A quarter of our fertilizer, I think, goes out in the fall.
In the fall, okay.
And that's really driven by two main drivers. One is fertilizer price.
Okay.
So, to add
Sure.
another layer of complexity to, like I said, farmers'
Sure.
decision making is very complex.
Yeah.
And so they have to think about the pricing. So in typically fertilizers are less expensive in the fall because of logistical reasons, like being able to store it. There's less demand, so it's at a lower price. Because one of the biggest challenges is the crops in the entire northern hemisphere need all that nitrogen in the same few windows time period.
Oh,
so if you
wow.
just think about the logistical challenge of getting millions of tons of fertilizer onto the landscape in a very short time window, I mean, that's why this is why it's been as much of the development is on the technology and engineering side. Like a lot of this is an engineering challenge of how do you move such vast quantities of, my dad always liked to say that farming is a materials handling problem because it is just vast volumes coming in, and then you got to haul it all out.
Oh, yeah.
And so it's as much of a logistical engineering challenge layered on top of this biological system that has all the biology happening. And then a human system is the other biggest piece of why it happens in the fall, is there are only so many people available to do the labor.
Okay.
And so whether you're a grower, your busiest season is during the growing season.
Sure.
And so, technologies are making it more efficient, like your labor become more efficient. Like, for example, just switching to irrigated pivots, which you can run on your phone, versus gated pipe where you had to be out there every day, flip or back a little further, siphon tubes, which my grandpa still, I'm like, it hasn't been that long ago. Even when I was a kid, my grandpa showed me how to set siphon tubes, and that's very labor intensive. But now that when you open up more labor availability in season, then you can start to think about how do you deal with nitrogen in season, and also making that more automated. So, but you still have to haul there's fertilizer tanks, and it has to get out to the pivot. You have to make sure it's working, and things inevitably break. And so it's just also this labor logistics piece. And so in the fall, once everything's harvested and in the bin, there's more time.
Sure.
And so those are the two main drivers, is the physical logistics, which drives price, and then the human logistics of getting the product out there. And so that's why a lot of folks still feel like it's in their best interests to do some fall application.
Okay.
If you pick the right type of fertilizer, which, they are, if you're fall applying. And then once we say 45 to 50 degrees soil temperature, the microbes kind of go dormant.
Okay.
They still work slowly, but they're mostly dormant. And so they're not going to mineralize that nitrogen. So during the winter, it stays in the soil fairly well. We kind of estimate, and here again, it's weather driven.
Sure.
How often? Because we know we get these really warms. And like right now, it's really hot.
Yeah,
before the growing season. So the microbes all wake up. They get active. They mineralize. But we estimate like 5% is lost between. These are really rough numbers. Between mid-November to mid-March. And then our biggest season, though, where it's an issue, so not so much as it's lost in the winter, because a lot of people are like, well, I'll fix it if I just put it all on in March or April. Well, you're really not saving much, because almost all the leaching happens in March, April, May, and June.
Sure.
If you look at the rainy season, that is a rainy season. So so we kind of think of this as a risk management equation. And so you're really trying to figure out, how do I minimize my loss risk? And then that gets layered with labor and price risk. But so in a loss risk sense, like preseason application is not a lot different than fall fertilizer application, because you still got all your nitrogen there during the rainy months when the crop isn't using it. Because corn does not really start using a lot of nitrogen until late June. And so the whole rainy season, if you've got it all out there, it's high risk. The other reason it's high risk, we get a lot of extreme weather events in Nebraska.
That's true.
So if you get hailed out in June, and you get no crop, and all your fertilizer's out there, you've spent all your inputs. And this is a price risk too. You've spent all the money. And then it's also an environmental risk, because all those inputs are out there on the land, but then your crop's totally hailed out. It's too late to replant, so it just sits out there. Or in a dry land situation, this gets talked a lot about in the eastern part of the state and into Iowa, is that if you got all your inputs out there and we get a major drought and you're on dryland acres, so your crop is essentially done, toast, you still have all those inputs out there, which are then a price risk for yourself as well as the environmental risk, because it's all just sitting out there. So when the rain kicks back on, that's in dryland situations. So what kind of drives it is more that drought rainfall cycle of if, and these are things that farmers have struggled with. And that's why we have, we try to have really high quality weather data. We've got our drought center, we've got Mesonet data. Like we're really trying to help manage that risk equation.
Absolutely.
So that we minimize in the end the health risk.
Oh, yeah, because it's basically just further illustrates the complexity that producers are dealing with. It's not like just a real, if they had an easy button to, fix a lot of things or kind of do X, Y, and Z, they'd easily do it. But they're trying to weigh all these different decisions and kind of figure out what makes the most sense. And then they get kind of the curveballs of the weather, like hail, for example, it comes in. And that's something that obviously nobody could forecast, that you're going to have those cases arise. So, yeah.
I do want to drill back down on the health stuff, but before that, we mentioned microbes. They're always, not maybe always, but they're active in the soil. Are they breaking down the nitrogen into a nitrate form, or is it released as a gas? Can you kind of touch on that a little more?
All of the above. And so soil microbiology is fascinating. So my background, I did a lot of microbiology work in other systems. So I love my microbes. But the nitrogen cycle, many of us learn at some point if we're in ag degrees, but I have always struggled to keep track of the multitudes of transformations that happen, and they're all microbially mediated. So certain types of microbes change it from one form to another and another microbe. So they're a whole ecosystem under there that are eating and living and dying. And so really what we're trying to do in agriculture, and I think there's a lot of movement towards this in the soil health space or regenerative ag space, is really keep those microbes active and cycling. I think that, that's kind of the short version of what we're trying to do. So, when it's cold, we can't control that. They go dormant.
Sure.
But anytime dormant is maybe not quite the right word, because they move a lot slower.
Yeah.
Is maybe a better way to describe it. But then once it's warm enough and wet enough, like if it's totally dry, a lot of them die. And so that's the other advantage with irrigated systems for soil health, is that we don't let it get so dry that you kill off your soil life.
Yeah.
And so, you really just want to think about how do you keep them fed and happy and water, just like any other living creature. They need food, they need water, they need shelter. And so it's that whole piece of how do you make an active ecosystem so that they can do all those transformations. And so, there's ammonia forms of nitrogen, there's nitrate forms, and I know there's other in-between products. And so nitrogen gets put into the protein of any living creature. And so the microbes use it as a food source, and it's also a waste product. So that's why it's really dynamic in that soil. Some of them in their process, some of it comes off as nitrogen gas. For a cool other research piece, we're looking at one of the things that I thought was cool that I didn't realize until a few years ago. I was like, of course, it's living and cycling up here where all the roots are. But I was like, there's not much happening in the deep soils where our groundwater is. Well, we have found, we being other researchers here at the University of Nebraska, have found really active microbial communities in the groundwater in those really deep soils. And so they're doing nitrogen transformations that we're just starting to learn about. And so there's pockets in Nebraska where we're seeing low nitrate levels, and it's microbially driven in these really deep soils. So there's this field of research on, can we start to, so we talked a lot about the ag side, but then on the treatment side, can we figure out what are the conditions that are leading to these microbes that are converting it, and what are they converting it to, and how, so if they're converting it to nitrogen gas, then that's kind of inert for our purposes, which is good, because once it's down there, we're talking about groundwater, so drinking water, we don't want the nitrate. or are they converting it to a different form and then it gets changed later? So we're learning. There's some really cool.
That's
so we do
cool.
these cores that are like 100 feet deep, and
Wow.
like you bring them into the lab and find out what's going on in the chemistry and way down there. And it's really cool. There's fun stuff. They'd be great people
How do
to
you
have here on the
get? I'm just
podcast.
curious. How do you get like pull? That's a pretty big core, 100 feet.
It is,
That's
and the cores are like
It's
4
huge.
inches across.
Wow.
And so they have this huge drilling rig
wow.
that's done here in the Department of School of Natural Resources. And so that it would be really great to have those folks on to come talk about it.
I'd
It's
love to
really
talk
cool
about
to
that,
see.
yeah.
It's cool to see, and they could share about this deep, that whole zone is called the Vadose zone is our
Okay.
science word for it. And so there's a whole Vadose zone study group. There's 3 or 4 faculty who are looking at the chemistry and the biochemistry. Like we got biologists that are looking at what's happening in that Vadose zone, whether it's biology or whether it's chemistry. And so there's some really kind of, still at the lab, but
Yeah.
maybe really exciting things in how
Sure.
we might be able to address nitrate once it leaves the root zone. Because
Yeah.
historically, we're like, well, once we lose it, it's lost. We're
Sure.
just going to have to deal with it. But there's these pockets we've seen where there might be some options for finding the right set of conditions where we can treat it once it's out there in the Vadose, and also up there on that piece. But and then we have to treat it. We could talk a little bit about that if you want. But
Yes, I do want to talk about the water treatment. But before that, I want to back up to kind of touch on more of the health
Sure, yeah.
issues, and then we can get into why we should treat it. You briefly mentioned the blue baby syndrome, where the child is essentially suffocating because they can't break down the nitrate, correct?
Right.
Is that something that occurs rapidly? I mean, are there early warning signs for parents to look for? Or?
Yeah, well, so the main thing is just test your water, which we can get into that more later. But on the health side, there are still occasional cases in Nebraska that I've heard about through my UNMC colleagues that they hear about it from clinicians. And I don't think we've had any fatalities, but they definitely see these babies in their clinics who you can tell that they're kind of suffering and not doing well. And there's global research. Like I said, I don't want to make this seem like it's just a Nebraska thing. This is a global challenge anywhere where we've got ag production.
Yeah.
And so there have been some global studies, health studies, looking at kind of chronic levels of nitrate for infants and children. And they're seeing some stunting and those sort of situations in that where they, don't have access to higher quality water. And so the turning blue is when it starts to get pretty extreme because you're truly not getting enough oxygen. But there can be this lower level where you're kind of chronically oxygen deprived. And I don't know enough about the clinician side to know the clinical symptoms of that. Like I said, I always lean on, well, you just need to test your water and make sure your water's safe if you're giving formula to an infant. Because there's many other things, like nitrate's just one of many things that you don't want in your infant's bottle. And so, and don't assume either that a bottled water source is better. We've done some testing where bottled water, they're required to test it yearly, but we've seen, particularly in some of the spring water that's out there, that it still pops above 10 in different parts of the year. That's been an interesting. And then there's other things in bottled water. So like you want to just test water.
Yeah,
Particularly
no,
for
well, no,
infants,
that's good.
because infants are really, because they're so small,
Sure.
they drink more water than an adult for their body size and some of those sort of things. And they're just more susceptible because there's so much growing and developing that happens at that stage. You just want to be really thoughtful about both about the water supply and make sure it's safe for that infant.
Have we drilled into any health concerns for adults or older folks who are drinking water with high nitrates?
Yeah, here again, very active area of research. But when I looked at the history, the first cancer studies based on nitrogen compounds, because like the nitrogen is very reactive, those were clear back in the 1940s as well.
Oh, wow.
They're finding in some industrial settings. So nitrogen can react with other things that are known and become known carcinogens. And so those are called nitrosatable compounds is our scientific word for it. So UNMC has kind of led the way for a long time in doing a lot of environmental health research as a whole. But again, it's globally studied because
Sure.
this is a challenge globally. And so there's been quite a few linkages made. There's some of these compounds we know are carcinogens.
Mm-hmm.
Particularly some of the reactions with other agrochemicals are known carcinogens. And so we know we see some of those in our water supply, and so we just know we want to stay away from those. But nitrate by itself has also been looked at because once you drink it, so an adult's body can break it down, but the things that it turns into are not always good.
Oh, sure.
So like I said, those nitrosatable compounds also happen in our digestion and in our saliva. It would be really great. I'm just repeating what I've heard from my UNMC colleagues.
Yeah, that's kind of
so
what,
they're the ones who really could tell you about the details of how that happens it happens both in your mouth and in your stomach. And but it can be offset by antioxidants. There's other health promoting compounds. So it's always in your body. It's kind of the same idea of you need to have a healthy mix of, and most of it's microbes, again, driving this. But we do kind of want to stay away from it as adults. Particularly the most at risk can be adults who have blood oxygen disorders, because in that same way of where infants can have blood oxygen, that's what we see for infants. There can be adults who, for various reasons, already have blood oxygen concerns. And then if you get that combination with your microbes are off and then they aren't breaking down the compounds, then it can turn into that same situation where the nitrate binds to the hemoglobin and makes your blood oxygen issues worse. And then like I said, there's some linkages with some forms of cancer, both pediatric and adult cancers. And those are really active areas of research to kind of tease out, particularly for adults, where we get exposed to a lot of things to figure out how much is driven by nitrate alone, how much is of these mixtures. But yes, it's generally not a good idea. We set a health drinking standard of 10 parts per million for a reason. And so even as adults, like for sure for your infants, it's a very acute problem for an infant. But even as adults, they do not recommend drinking it long term.
Yeah, we'll definitely have to get some folks from UNMC on. That'd
they
be kind of fun to just
Mm-hmm.
kind of talk to them and kind of dive. Because this topic as a whole, we could be here for hours kind of going on. Because the point is it's very complex, as you alluded to. And there's a lot of moving pieces there. And you mentioned, so obviously testing your drinking water. One of the things, and I wanted to just briefly mention this from the farmer side of things, obviously a lot of work, and you alluded to this earlier in the precision ag side. Now variable rate technology, for example, is really evolving. There's a lot of interest in that realm moving forward. I can strategically apply fertilizer at various rates across my field, back to that precision. But then on the kind of the drinking water side, I know, for example, Hastings, where my wife's originally from, they have a large reverse osmosis system there, and I know that's something that's that technology that is there to help address that. But could you maybe explain a little bit about, some of those things that, help folks that are maybe in a location where they, especially if you're in a rural area where you don't necessarily have a large multi-million-dollar system put in place. So.
Well, and we'll split it into two buckets because I'm like, we can first kind of talk about most people live in even small towns to bigger cities, and how they treat their water is very different than if you have a private well.
Absolutely.
So we can start on the city side, since that's where most of us live. Because if you have a water supply that I should have looked up, I can't remember if it's 6 or 9 connections, I think is the limit. Once you get multiple people on that connection, then you become a public water supply.
Oh, okay.
And that's when we do have protections that are federal. So everybody in the U.S. is covered by, if you have a public water supply, there's some minimum standards that water supply needs to meet. And so, in general, we've put a lot of investment, both infrastructure and policy investment, to make sure that the water that we drink is very safe. And so they test for over 90 compounds. I think last time I looked, it was 93 that get tested. Some of depending on levels, like if it's something that changes, that testing can be daily. And so it's a really cool, if anybody ever gets a lot of your utilities give open houses, go check it out.
Sure.
It's very cool to see the infrastructure that brings clean water to the vast majority of our households. in Nebraska, 85% of us get our water from groundwater. The 15 that's left is surface water, and that's in Omaha because they get not the whole city. Omaha has multiple sources, but one of their big sources is the Missouri River.
Sure.
And so, they're looking for different things depending on where that water is coming from, but they're testing, like I said, certain things are daily, weekly, yearly to make sure that those 90 some compounds are within safe thresholds. And nitrate is one of those. It's been, like I said, that standard goes back many decades of keeping it below 10 parts per million of what's delivered to a home. And so in our cities, they're doing a lot of that work for us. And, and so that's what shows up in your water bill is that infrastructure to deliver it and to test it.
Sure.
And then in places like Hastings, it is driving higher water bills to have to treat for nitrate. There's maybe a dozen or so communities who have had to install reverse osmosis in their public drinking water systems to keep that nitrate level below 10 parts per million because, in some cases you can find cleaner water and blend it. There's other options they try to pursue because filtration is expensive.
Oh, sure.
It's a lot to maintain. You need a highly skilled person. And so, for example, the first reverse osmosis that went in a public water supply in Nebraska was Creighton in 1993.
Oh, wow.
They're
That's
up in the
cool.
northeast part of the state.
Sure.
But they're a fairly small community, like 1,200 people, I think is what I was just up there earlier this week. And I'm like, I think it was 1,200 is what I saw on the population sign. And so that's a small number of people to spread that complex of a system across. And they only have a couple water operators. And then, in small towns, your utilities people tend to cover all utilities. They're not like dedicated. And so when you go talk to them, they're like, oh, it's finicky. I think it's something close to that he used to describe it because it's this highly technical system.
Oh, sure.
Those filters can clog. Things can, it's a lot more pumps, a lot more things to go wrong than just like pumping it out of, where you just have a pump that's sending it out to your. And so and then you have with that added skilled labor. So you also have on top of the system expense, you have higher employee expense. And so for a really small town that has like one person that does everything, they might have to hire a whole nother person. And that person needs some technical skills. So it's so all that then has to get split across a few hundred people. So that does drive those prices that people will see. So like so they're doing all this work to keep your water safe, but it is not cheap. And so that's one of the challenges, particularly in many parts of the state, since we know we've got more nitrate coming, there'll be more of these towns that have to install these. So it's just an expense that we're seeing, and historically those expenses were covered also partially by state and federal loans that come from taxpayers across the whole nation. So when we start to talk about fiscal policy, how do we cover this? It's covered through taxpayer dollars. And so filtration is expensive. In environmental sciences, we often talk about it's cheapest to make sure the pollutant doesn't get there first.
Sure, yeah. So
that's why we kind of started today talking about how do we keep it out in the first place. But like I said, this has been such a longstanding problem. Some of this is inevitable cost. So we just need to be planning for that now. We're going to have more of these communities who are going to have this added cost to their water system.
And doesn't, maybe I'm mistaken here, but Nebraska Department of Environment and Energy, do they have programs that kind of help maybe offset some of those things for landowners, especially in those rural communities that may not, to be able to get some, like, say, reverse osmosis system or something similar, to help with some of that process?
Right. And ND just had a really nice study, drinking water nitrate study come out, and they're using that data to help inform on the community, on the public water supply side, to help inform, like, how can we help communities at different stages? Because there's some communities that are at lower risk. There's, for the, and this is what they kind of use that study to do, is kind of help place communities and how much risk do they have for needing to go to treatment. Because that's kind of the last option is how can we prevent as many communities as possible. So we've got a wellhead protection program that's been in place for a very long time, which is kind of one of those first stage things of how do we protect these wells, particularly for public systems. And so that's all voluntary, working with landowners to really prioritize working in wellhead areas to protect them. And so that's kind of the first tier. The middle tier is, well, you're getting higher. You need to start doing some more advanced things, start looking at, can we find wells that are lower and do some blending? And then the other piece is when you're kind of in that inevitable track towards you've got to install some sort of filtration unit, then you start looking for grants. How are we going to fund it? What technical expertise do we need? And so, again, if you want to continue this track, you could have the NDE people in to talk about kind of that pathway, and they're using data. Again, we try to be very data driven. I think it's one thing that Nebraska has always been very good at is being data driven in our decision making, whether that's a landowner or in our policy space. And so that's kind of where they're at in helping communities think about how do we stay ahead of it so that we can hopefully have fewer communities that have that expense, because it can be in a town of like 60 people. It's gotten to where they just I'm trying to remember which town that is, but they decided to just start supplying bottled water. Like they got rid of their public water supply because it was too expensive. They couldn't do it it was a town of like under 100 people. And so then you have, there's a logistical challenge, and bottled water is not perfect either.
Yeah, like you said, you're getting bottled water that might also have issues.
Right. And then there's other towns have decided, well, we're going to put reverse osmosis in everybody's home, which is then intrusive to that homeowner because you got to change filters at least once a year. So now you've got a utility person that needs access to your home, and it becomes a challenge when you get to that stage, particularly for these really small communities.
Wow. Yeah.
So if you're an individual who is concerned about their water, whether they're rural or urban, or even if you're not concerned, test your wells. But how can we test our water to make sure it's safe?
Yep. And so on that private well place is what they call it. So that's when you have your own well for your home. And there's even some folks, like it's good to know where your water is coming from. Most homeowners, I think, do. But even some kind of peri-urban spaces, there's a lot of legacy homes that aren't on city water. You're on your own well. And so this counts for those too. You might still be in kind of a urbanish setting, but you have your own well. And so in all of those circumstances, they're fully exempt from any of the federal protections. And that was, intentionally set that way when it was, because they didn't want it to feel burdensome. They didn't want a private well owner to be required to do 90 tests and some of them daily. Like that's not something the average homeowner wants to have anything to do with. But that being said, we do all that testing in public water for good reason. And so it's worth finding out what are the issues in your area. So we've talked a lot about nitrate because it's a very common one, but it is not the only thing. And so it's great to talk to your local NRD or your local communities to find out, well, what are you seeing? Because they are doing all the testing. What are you seeing as water quality concerns? And then you should test for those as a private well owner. And there's a state water testing lab, and there's a couple private water testing labs. So we've got at least 3 in Nebraska that do this testing. Nitrate and E. coli are like the bare minimum, and those are under $40 to test. And we recommend you test those every year because those are both things that can change fairly quickly. But it's still good to, like I said, talk with your local folks, find out, is there heavy metals? Because there's many places in Nebraska where we have heavy metal issues, or we have uranium issues, or there's many different things that could be a challenge. And at least test once. It gets kind of expensive, but this is your family's health. And so I think it's really worth it. So, at least test once for kind of that broader scope of things that might be a problem in your region, and then kind of do this annual testing on the nitrate and E. coli side. And that'll give you a really good picture of what's happening in your water. And the reason we say to test yearly is because, like I said, with this kind of block of nitrate coming down through the soil, it changes year to year. And in most places, it's still rising. So even if you tested 15 years ago, it may not still be safe. Like, you don't want to make that assumption. So that's really why we encourage people to just keep an eye on it. And E. coli comes from, that's an animal source of like, are you getting, those will make you sick right away if you got E. coli in your water. And so Those are the two
Can you
common.
get results from like say a public water source, like to see kind of what they're?
I should have said that.
I'm
yes.
kind of curious.
Yeah, so with the public water supplies, they are required also as part of the Clean Water Act to do an annual report.
Okay.
And so every public water supply, and I think they're required to mail it.
Oh, okay. Sure.
I think. I don't know. They may have changed it more with email and
Oh, yeah.
more electric.
Sure.
Maybe they can do electronic now. But a lot of places will still physically mail it in particularly your smaller towns. And even if you don't get that, you can request it from your city utilities. Pretty sure Lincoln's is still, last time I looked, it's on their website. And so you can see the most recent annual report of results. So yes, on the public water supply, you get that as part of it. And then like I said, if you send as a private well owner, you send it to a lab, they'll send those results back to you. They're usually very good at any of those labs, state lab or private labs, of if like kind of talking you through what it means. They've kind of got some good, and we can do that too in extension of if you have questions about like, what does my water test mean? We can kind of talk you through that. They've gotten pretty good at visualizing. Is it in the safe range? Is it something you should be? And then the thing, if you're doing that annual, you can kind of watch the trend. So if you see it trending up, you really need to be starting to think about getting some treatment if you're headed that way.
Sure.
And on that treatment side, for a homeowner, there's a few options. Reverse osmosis is the most common. We've heard the most about it. There was last year a state program to help pay for those as part of that NDEE effort. There's now a state tax credit, rebate. I don't remember the right terminology. If you put one in, you can claim it as a tax rebate. So definitely check that out. If you've done it in the past year, it's tax season.
Oh yeah, sure.
If you put one in, they now have that program available. But so reverse osmosis is the one that's most common. You can go get them at a hardware store. That's what when I lived out of town, I went and bought one, installed it myself. They're like $400 and it's fairly basic. Like I did it myself. It takes a drill and, yay me, plumbing. I did basic plumbing, but you can definitely hire a plumber.
Sure.
And so the one I did is just for our drinking water out of our sink.
Yeah.
But if you want to do something for more parts of your home, so like if you've got a refrigerator that you also want to make sure you get a clean water line over to your refrigerator because that's your preferred place, or if you prefer to get it out of your bathroom at night when you're drinking, or if you have kids who that's so you may want to hook up more of your faucets. You can definitely hire a plumber to connect all of your faucets, but that's something to think about is like, where are you getting your drinking water? And also you want to think about what you cook with. So like if you make a big soup that's got 6 quarts of water in it or something, you want to make sure that's from that clean source. So just think about your house and your household and where you get your drinking water. And so if it's straightforward and you want to do it on just one source, you can do that yourself. Or if you want to get a plumber to kind of help you do a more comprehensive package for your whole house. And this is one of the reasons to do that more comprehensive water testing as well. Because like nitrates is just a concern if you're drinking it. But some of those other water contaminants are also a concern for bathing. And so you want to get a more whole household filtration system for some other contaminants. So for nitrate, it's really a drinking issue. And so you can do a little bit more basic, smaller system. But
that's cool.
I said that, as a homeowner, that's just part of owning your house is, you have to think about, does the roof need repaired? You also need to think about, how is my water set up sufficient for our family needs?
Yeah, that's super
so
cool.
Please, if you're listening, test your water.
Yes, absolutely.
Test and treat. Test and treat. That's the short version.
No, this was a great episode. We covered a lot of stuff and a lot of information that I learned personally. And not to make you nervous, but this episode was to set the stage around nitrates. So then, like you were saying, you need to bring in so-and-so. That's kind of the plan down the road, is to bring in some of these other areas and discuss them further in depth. So thank you very much. This was very informative.
Absolutely. Yeah, I really appreciate it, Crystal. I know I learned a ton. I just, this is an area, it's just, there's so much information there. And I think it's so important that we get this out. And that's, one of the things I've really championed in trying to do that within our extension program. And obviously with the podcast here as a whole. So yeah, thanks so much for coming on.
Thank you for having me as well.
Yeah,
And I think it sets a great stage. I want people to come away knowing that there's a really large team of people who are helping address this issue. There's people here on campus. There's your local and state policy, federal policy folks. There's the growers, whether you're a grower or the people living around you. This is a topic that there's a lot of interest. There's a lot of dedicated people that have dedicated careers. Like, this is a multi-generational thing at this time that we all work together to kind of protect this foundational piece that we have here in Nebraska of really great water.
That's awesome. That's
Well
a great
said.
way to end it.
Thanks again, Crystal. Thanks for listening, everybody.
Thank you.
Wild Ag is part of the Natural Resources University Podcast Network. If you enjoy this podcast, please leave us a review so others can find us and tune in.
And we want to hear from you. You can submit questions or topic suggestions to us at wildagpodcast@gmail.com. That's WILDAG podcast@gmail.com. Thanks for listening.